I'm going to take the fourth root of c to the fourth, which is c, bring that outside this radical sign, and what's left underneath is 2c. In my denominator, I'm going to take the fourth root of 16, d to the fourth, and d to the fourth, so I'm going to have 2d squared, right, because I've got the fourth root of d to the fourth is d, fourth root of this d to the fourth is d. And then what's left over here under the radical sign is 2c to the 2c, the fourth root of 2c, sorry. And so I have the fourth root of 2c over the fourth root of 2c, which is 1. So all that's left when I simplify it is 2c over 2d squared. Sorry about that. Okay, now like I said, there's more than one way to do it. You could have simplified 2 over 32 as 1 over 16, and c to the fifth over c is c to the fourth under the radical sign, and then simplified, but I chose to go a different route. As long as you're careful, you will still get the same answer. Now we've got number 8. 16 to the 1/2 power plus 16 to the 3/4 power, and that sum to the 1/2 power. So the first thing I notice is that 16 to the 1/2 power is the same as the square root of 16, which is 4. Now 16 to the 3/4 power is the same as the fourth root of 16 cubed. Well, the fourth root of 16 cubed is 2 cubed, which is 8. And that whole thing still to the 1/2 power. So I've got 4 plus 8 to the 1/2 power, which is the same as the square root of 4 plus 8, which is 12. And when I simplify 12, I get 2 radical 3. And that is the solution to number 8. Now number 9 is an exercise in rationalizing denominators. So I've got radical 1 over a and the cube root of 1 over b. So what I'm going to do here, I'm going to break each one of these into numerator and denominator. So I'm going to have radical 1 over radical a plus the cube root of 1 over the cube root of b. And and what I need to do in order to rationalize these denominators is I need to get these radicals out of the denominator. So with my first term, let's work on this one first. I've got 1 over radical a, because the square root of 1 is 1. And I need to get a perfect square in my denominator, so I'm just going to multiply by the square root of a over the square root of a, which will give me the square root of a over the square root of a squared, which is a. Now let's take a look at our second term. I've got 1 over the cube root of b. And what I need in my denominator is a perfect cube. So I really need to multiply numerator and denominator by the cube root of b squared. Because what that's going to give me is cube root of b squared in my numerator. And then in the denominator, I'm going to get the cube root of b cubed, which of course is the same as saying b. So when I just simplify this final answer, I'm going to get radical a over a plus cube root of b squared over b. Remember, you just need to, in this denominator here, you just needed to multiply this denominator by whatever it was going to take to give you a perfect cube under that radical sign. Okay, so here we have, this is number 10, and I'm going to simplify my numerator first. The cube root of negative 27 is negative 3. I'm going to bring that outside the radical sign. A to the fourth is really a cubed times a, so I'm going to take the cube root of a cubed, which is a. And so the only thing left under my radical sign is the cube root of a. Now in the denominator, I'm going to take the cube root of 8 and bring it outside the radical sign, which is 2. And that leaves cube root of a under the radical sign. Well, look what I've got. I've got the cube root of a over the cube root of a, which is 1. So my solution, or my simplified answer, is negative 3a over 2. Okay, number 11, we've got a radical equation. What we're going to do is we're going to square both sides. So that will give us 4x plus 21 equals x squared. Since I've got a quadratic here, what I'm going to do is put everything on one side of the equal sign, get it equal to 0. So I'm going to subtract 4x and subtract 21. So I'll get x squared minus 4x minus 21. And then I'm going to factor it. So I'm going to get x minus 7 and x plus 3. When I set each of my factors equal to 0, I'll get x equals 7 and x equals negative 3. But what I've got to do now is I've got to check for those extraneous roots. So let's rewrite our equation. Square root of 4x plus 21 equals x. So for 7, it's going to give me the square root of 4 times 7 is 28 plus 21 equals 7. Square root of 49 equals 7. Well, that's true. So x equals 7 is definitely a solution. For negative 3, I'm going to get 4 times negative 3 plus 21, square root of that, equals negative 3. And I know this will not be a solution because since we're talking about the principal square root, we can't have negative answers here. So the only solution is x equals 7. In order to simplify the expression in number 12, I need to rationalize my denominator, which is the cube root of 16. And I need to multiply this by whatever this denominator, by whatever it's going to take to make it a perfect cube. Now I know the cube root of 16 is the cube root of 4 times 4. And if I multiply it by the cube root of 4 again, that's going to give me a perfect cube in my denominator, because I'll have the cube root of 4 times 4 times 4, which is 4. So here we go. I'm going to multiply top and bottom by cube root of 4. In the numerator, it's going to give me the cube root of 4 times 2, which is 8, plus, 6 cube root of 4 over the cube root of 64. And now simplifying, know the cube root of 8 is 2, plus 6 cube root of 4. Sorry about that. And the cube root of 64 is 4. Let me just clean that up just a little bit. There we go. Now, what I can do is I'm going to reduce everything by a factor of 2. So this becomes 1, this becomes 3, this becomes 2. And so my final simplified answer would be 1 plus 3 times the cube root of 4 over 2. Okay, so in order to simplify our expression in number 13, I got to simplify each of these radicals. So I'm going to just break them down into their factors, looking for perfect square factors. 150 is 25 times 6. This is subtraction, sorry. 48 is 16 times 3. And 54 is 9 times 6. So now I'm going to take the square root of each of these perfect squares, and that'll give me 1/5 times 5, radical 6, minus 4 times 4, radical 3, plus 2 times 3, radical 6. Let's just clean that up a little. 5 times 1/5 is 1, so I've got radical 6 minus 16 radical 3, plus 6 radical 6, and now just combining my like terms, 6 radical 6 plus radical 6 is going to give me 7 radical 6 minus 16 radical 3, That's my simplified answer. Okay, number 14, I've got three expressions that need to be simplified. Let's take a look at each one. The first one, we're going to have to rationalize that denominator. So 12 over radical 2, we're going to multiply that by radical 2 over radical 2. The second expression, we're just going to need to get some perfect squares out from under that radical sign. I'm going to break 32 into 16 times 2. And then this last one, we just have to square it. So this is going to be 2 radical 3 times 2 radical 3. So let's see what we've got. We're going to get, in the first case, we're going to have 12 radical 2 over 2. In our second expression, I'm going to take the square root of 16, so that's going to be 4 radical 2. And in this last expression, I'm going to have 2 times 2, which is 4, times radical 3 times radical 3, which is 3. So let's simplify a little more. 12 over 2 is 6, so I'm going to get 6 radical 2 plus 4 radical 2 minus 4 times 3, which is 12. And then I'm just going to combine these little puppies. I'm going to get 10 radical 2 minus 12. And there is our simplified answer. If you wanted to factor out a 2, you can do that, and then your answer would be 2 times 5 radical 2 minus 6. Either answer is correct. So for number 15, we've got some expressions with rational exponents, and we need to express them in radical form. Remember that the denominator is the root, the nth root, and the numerator is the power. So a to the 6/5 is really the same thing as the 5th root of a to the 6th. Now here we've got 5x to the negative 1/2 power. That negative sign means that this expression is really in the denominator. So we've got 1 over 5x to the 1/2 power, which is equal to 1 over radical 5x. We'd like to rationalize that denominator, so we're going to multiply it by radical 5x over radical 5x. And so our simplified answer would be radical 5x over 5x. Now let's take a look at the next one, 10n to the 3/2. So that's going to be the same as the square root of 10n cubed. I could also write that as the square root of 10n cubed. These two expressions are equivalent. Last one, or not the second to last one, I have a plus b to the 3/4, which means I'm going to have 1 over a plus b to the 3/4, which is going to be 1 over the 4th root of a plus b cubed. Now I want to rationalize this. I've already got 3 factors of a plus b. So all I have to multiply it by is the 4th root of one more factor of a plus b. 4th root of a plus b. Sorry, I'm out of room. And so what that's going to give me is, in my numerator, the 4th root of a plus b, and now I've got a plus b to the 4th power under that 4th root sign, which is just a plus b. So this would be